Okay, so why don't we get started here? First of all, some announcements. So assignment number 5 is due on Wednesday at noon. Some of you may also have noticed that Stat 822, which is one of the required courses that most of you will be taking next semester, it's listed as 4 credit hours for some reason online. It should be 3. I have talked to the appropriate people to get that fixed, and it eventually will be fixed. For the first time in the Department of Statistics, we are actually going to do online course evaluation. So at the end of the semester, every course is going to have a particular evaluation where you can make comments about what you thought of the course, what you thought of the teaching and stuff. And we're finally, after a lot of work by myself and Steve Lodunga, we are actually now doing online course evaluations. You will receive an email, I would imagine, by Monday regarding it. So please be aware of that. Now, if we have time at the end of class today, I'd like to discuss a little bit about what to expect with an evaluation and a few other things. And if we don't get to it at the end of class, that's fine, but I would appreciate if you not do the online evaluation until we have had like a 5-minute discussion about it, okay? Okay, so are there any questions before we get going here? Okay, so today we have our third and last guest speaker, Pavel Chernyavsky. Did I pronounce your name again right?
Pavel's fine, and when I get a teaching position, I'm going to have my students call me Dr. C. I think that's just it's just going to be easy for everybody.
So Pavel's going to do a little introduction to himself on slide 2, but I just want to briefly mention a couple things. Pavel took a number of, Pavel first graduated in 2015 with his PhD from here, so he's a recent graduate. Pavel took a number of, or a few courses from me, and actually was my master's student. I was his advisor. And one thing that I thought that Pavel did very well, that I think also should try to emulate, and that is basically, Pavel did a good job of taking an initiative, and he showed a passion for what he was doing. If there was stuff that he didn't understand, he would go out and try and figure it out himself. And those are the kinds of qualities that we look for in PhD students, and those are the kinds of qualities I urge you to try to emulate. Okay, so with that then, Pavel, when you're ready, go ahead.
All right, well, thanks, Chris. Thank you for giving me a chance to talk to your class. This was a fun presentation to put together. It gave me a nice break from the usual dull research that we do here at the Cancer Institute. All right.
That doesn't sound good for those who might want to work there.
Oh, I joke. I kid. No, we have a lot of fun here. And as soon as I figure out how to navigate away from this screen, alrighty, let's try this again. All right. So a little bit about me, just so you guys know where I'm coming from. I was born in the Ukraine in 1985. 6 months before the Chernobyl accident, if you kept track of that kind of stuff. I immigrated to New York City in 1996. I got my bachelor's degree in economics from State University of New York at Binghamton. My master's degree was in statistics with Chris, as he has mentioned. And my PhD in 2015, I graduated in May. And I got my postdoc at NCI, the National Cancer Institute, in July. So, I'm back in the job market, and it seems like it's just so soon, but that's just the life that we lead here. And I've recently had to write my research statement again, and the opening paragraph, I wanted to kind of think about what it is that I do. At a certain point, you figure out what you do and what you don't do. So, as a postdoc, my main job is really to conduct research, publish papers, but I think that I'm grateful that publishing my dissertation is a part of my job, so I don't have to do it, on my own time. I don't have to hide my dissertation work from my mentors. And also finding a permanent position is a part of my job. And that is remarkable, because this is the only time I will actually be paid to search for the next job. Think about that. That is amazing. My research broadly, methods and applications using spatial and spatiotemporal statistics. And really, I think if I had to put myself in like an audio bit, like a tagline, I put spatial thinking where spatial thinking hasn't been. I incorporate spatial thinking into problems where it hasn't been used before. And that's a way, I guess, of pigeonholing me, if you will. So a bit about my projects, and the dissertation is the first major project that most of us do. I used EEG data, so that's electroencephalographic data, collected from college athletes, ran some spatiotemporal models, and then used the model parameters to try and differentiate between athletes with and without traumatic brain injuries. What we see on the screen right now, and hopefully it's moving and animating, is actually 5-dimensional data. So we have 3 dimensions in space, we have the 4th dimension being time, and the 5th dimension is, of course, the quantile of the electrical signal. So I thought this was a cool way to illustrate what spatiotemporal data looks like. So you can see at any one given point in time, nearby spheres or channels, there's actually 256 channels that are located on the scalp. The nearby channels are more similar than the ones that are farther apart. And also, as the time progresses, you see that nearby time points are more similar than time points that are far apart. So this is an example of what a spatiotemporal data set might look like. And if you're wondering, this particular subject, in fact, did not have a traumatic brain injury. This is a healthy person. So moving on, my first postdoc project was really kind of a, I like to think of it as a meat and potatoes. This wasn't as exciting as spatiotemporal analysis with traumatic brain injuries, but this is still, I think, what I hope to be a useful study. One of my collaborators noted that background gamma radiation in the house is linked to childhood leukemia, in that the risk of leukemia increases as background gamma radiation, indoor background gamma radiation increases. And they are in the UK. What you see on the screen, the gray dots, are actually 10,000 observed indoor gamma radiation doses. And my job was to figure out what statistical model predicted kind of the full surface best. And so we evaluated a number of models using a holdout sample. It's not important. You guys can read the paper. The paper's out if you're particularly interested in this stuff. But this is kind of the final output of this particular project. So you can see, for example, that down in the southwest, there's not a lot of people who live there, but that is where the doses are highest. In and around London, which is this area here, they're generally lower. Here in the middle, we have Manchester and Leeds. They're a little higher as well. And so right now we're using this model to try and interpolate or predict the dose rates for about 126,000 people for a case control study. So somehow, along the course of my postdoc, I got away from cancer a bit and started dealing with mortality, like all-cause mortality. If you guys follow the news, this is kind of a big deal. To put it bluntly, white people are dying and they're not sure why, or they do think they know why, and it's drugs. So this is the first of at least 2 studies that I'm involved with. I'm a second author in this paper, and we just got really positive reviews from the Lancet, so we're kind of excited about that. So what you see on the screen is percent change in overall mortality for different ages, different sexes, and different races. API down here on the bottom is Asian Pacific Islanders. AIAN is American Indians and Alaska Natives. So for example, the way we would read this is a 30-year-old white woman. For a 30-year-old white woman, total mortality is increasing by about 2% a year, which is quite a bit. If you look at American Indians and Alaska Natives, it is just bad, right? For 30-year-olds, it's increasing at 4% a year. Really, I think representative of many issues in that community, and I think that's what the Lancet was interested in. Also, if you look at Hispanic, Latinos, Blacks, and Asian Pacific Islanders, across all of the age groups, mortality is dropping, but for white Americans and American Indians, that's not the case. For younger people, mortality is increasing. So I think this just serves to demonstrate that even though I work at the Cancer Institute, I'm not bound to work on cancer projects. In fact, this was the director of my department that urged me to work on this project because, in her own words, the fact that total mortality is increasing, that means that something is offsetting all of the advancements we've made with cancer. And there have been many over the last 20 years. Survivorship is increasing steadily, but still, in this younger population, something, opioid drugs, is offsetting our progress with cancer. So I'm not bound to work on cancer-related projects, even though obviously cancer is a big deal.
So what kind of models, statistical models, are you using there?
I'm sorry, right. So these are age period cohort models, which are very popular in descriptive studies. They are essentially looking at changes in rates across 3 time dimensions at the same time. So you have ages, which you can think of as a kind of a time series. There are periods, which are calendar periods. In this case, is 1999 through 2014. And cohorts are the birth cohorts. So for example, I was born in 1985, I would belong to the 1985 birth cohorts. And these were pioneered in the early 80s by a guy by the name of Ted Holford, who's currently at Yale. And they've really been used a lot to describe kind of changes in population level rates. There are many references out there. So this is just a simple, or maybe, I don't know, simple for me, but it's a straightforward application of these models. Nothing new statistically happened. You know, we just applied the models and made pretty figures like this one.
Okay.
So because I started working with age period cohort models, I saw some ways to, and maybe my mentor wouldn't like me saying this, but kind of modernize them a little bit. And in particular, these models estimate a lot of parameters. They estimate, intercept 2 trends and then a whole lot of terms to kind of capture what is left over once you have estimated the intercept, the age trend, and the birth cohort trend. So I felt that, nearby ages and calendar periods and birth cohorts have got to be correlated. There's just not that much changes that happen when you go from the age of 40 to 41. Or when you go from 1995 to 1996. There must be something there. And so I developed an age period cohort model using a spatial random effect. And what I have on the screen is a demonstration of this. So we start with a simple kind of trend. So this is just a plane in space. The ages are on the horizontal, on a vertical axis. And birth cohorts are actually diagonals that are running from left to right. So we fit the trend, and then what is left over is being picked up by a single spatial random effect. And areas where that spatial correlation is visible, I kind of circled. So we see in the top left-hand corner, we see blue around other blue. So low values of the random effect are around other low values. So that's spatial correlation there. Here we have this broad area of positive random effect values. Here we have a low, and here we have a high again. And then we just combine the 2 together, and we have this fitted rates. These are the predicted brain cancer rates, actually, for a particular age group in a particular calendar period. So using a simulation study, we showed when this model outperforms the traditional model, and in particular when there is overdispersion present. And we also showed that when there is overdispersion present, the traditional model has biased trend parameter estimates, where this one, the bias is substantially lower. So this is in a review in Stats and Medicine. It's been in a review since March. The status has been, and this is just my frustration showing, but the status has been evaluating reviews for the past month. And any day now, I will hear about this particular project. And it's funny because one of the associate editors for Stats and Medicine is the director of the biostats department here. And so I think he was just saying that I need to just be patient because 9 months is very standard review time for Stats and Medicine.
This is the first review?
Yes. I know. And of course, I'm hitting the job market, and so I would love to get this, as at least, accepted with revisions or something like that.
At least one thing I do. I mean, I like Stat in Medicine. I think it's a good journal.
Oh yeah.
But if biology-related research, I usually try to go to biometrics first because they're noted for having quicker reviews. You'll have something back usually within 3 months.
Yeah, that's maybe that was an oversight. My mentor had an age period cohort paper in Stats in Medicine, and I think that's why I went that route, because I felt they would be familiar with it or they would be interested in it. But yeah, biometrics or even biostatistics, both of those I think would be quicker review times. But anyway, learning experience. Everything once you're a postdoc, everything is a learning experience. And so here is the application portion of the paper. So panels A and C are the observed cancer rates, brain cancer on top, ER positive, which is estrogen receptor positive breast cancer in situ. I'm learning a bit about cancer. Maybe shouldn't be surprising. I'm a postdoc at the Cancer Institute. Estrogen receptor positive breast cancer is among the most treatable breast cancers. Also, breast cancer is important because it's the most common cancer among women. So for brain cancer, we see this nice smooth surface. Something interesting, if you look at 80-year-olds, we see that incidence of brain cancer is increasing among 80-year-olds. That is interesting. I think that is a product of the fact that people are living longer and they're having a chance to develop brain cancer. I don't think that there's something ecological or weird going on. People are just living longer and they now have a chance to develop this rare cancer, whereas before they were dying before they got to 84, 82, and they didn't have a chance to develop brain cancer. That is my personal opinion. That is what I put in my paper as well. This breast cancer, I have no idea what's going on here. If you're wondering why we're looking at such a small age group, we're trying to control for screening effects, and so we needed to pick an age group where women get screened at similar rates. So before this age group, women are screened a lot less. After this age group, you're getting into Medicare, so you get screened a lot more. These patterns are, I have no idea, guys, but I think it looks cool, kind of a based and range thing going on there. Look, this model fits both well-behaved data and not well-behaved data, and I think that's what we were trying to illustrate with this application. So I don't know, guys, stop me if you have questions. This is supposed to be really interactive, and I'm just showing you eye candy, really. So
what will be a good course for students to take in order to be able to do this kind of stuff?
I mean, categorical data analysis with Curse Builder would be the first one. I mean, I'm using a lot of that stuff, and I looked at your book, Chris, and you do get into some random effect models.
Yes.
I
added after your class.
Right, and what is spatial statistics than a spatially varying intercept? That's really what we're doing. We're having a fixed effects model, and then we're adding a random term that is picking up stuff that is structured in space, or space and time, or just time. You can add that spatially structured random effect to anything. You can add it to the intercept, and that's kind of your standard spatial model. You can add it to a trend. And now you have an exciting spatially varying trend, and I'll have that later in my presentation. So I think it all starts with kind of that stat 971, generalized linear mixed models.
It now will be 822.
822, so changing all kinds of things, yes. And I think just trying to understand both the specific application and really trying to understand how they can generalize into other areas. So even though I'm dealing with ages and calendar periods, there's no reason why we couldn't treat this as a coordinate, right? And that's what I'm doing here. This panel A should not look that different than a weather forecast to you guys. Something is high over here and low over here. Well, we can treat this stuff as a two-dimensional or three-dimensional coordinate. And that's the major contribution of this paper.
Did you take the spatial analysis course here?
I did not. I taught myself spatial statistics.
Okay. So we do have a spatial analysis course. Pablo's PhD advisor, Dave Marks, was the main one who taught it. But one of our new hires does have spatial background, and I hope that we will be able to teach that as an elective course in the future.
Right, you know, I'm using kind of likelihood-based computation in this paper, kind of relying on H likelihoods. If you guys have read the kind of the seminal 1996 paper by Nelder and H likelihoods, I don't know if Chris, you know what I'm talking about.
I've never heard of age likelihoods before.
Like H as the letter H.
Oh, as in the letter H?
Yes. Like hierarchical likelihoods.
Oh, okay, hierarchical, yes.
Yeah. It was pioneered by Nelder and Lee in '96. I had to read through their long paper, and that was a tough read. That was a very tough read. Some tough language in there, and very smart British people. That's well, Nelder is. Lee's at the I think Seoul University. Anyway, this is done using likelihood computation. Obviously, you can reparameterize everything in a Bayesian way, and if you're interested in spatial statistics, you almost absolutely have to take Bayesian, a Bayesian approach. It's almost the de facto way of estimating these things. So this is my latest and greatest project. I was lucky enough to actually win a paper competition with this project, and so I get to travel to an extra conference next year. So I get some money to travel to a conference. I'm considering the Royal Statistical Society meetings in Scotland next year. I have some collaborators at Oxford, so the guy said if I'm in the neighborhood, he'll buy me a pint. So I'm gonna show up at his doorstep and say, you know, it's go time. So. But this is an extension of the mortality project. We're looking at the U.S. overall, but clearly there must be differences by states. There also must be differences by county within states. So I developed a spatially varying age period cohort model where I'm adding a spatial random effect to the intercept, the age trend, and the temporal trend. Now, these random effects are correlated both in space. So for example, you know, here in the deep south, the relative risk values are going to be correlated. Here in the upper kind of northern mountain states, the relative risk values are going to be correlated. But also, if you know anything about random intercept, random slope models, it's often the case that intercepts are correlated with the trends. And so the random effects are not only allowed to be correlated spatially, they're also allowed to be correlated among themselves. So in particular, you see that the high baseline risk in the northern mountain states corresponds to low age trends. So there's actually a negative correlation there. And you can see that, for example, on this panel here, the highest temporal trends also happen in states where the baseline risk is elevated. That's a positive correlation. And that's a really concerning finding, right? The risk is already high and it's increasing. So it's really pointing to a divergence over time. You can also see where the baseline risk is low and it's decreasing. So it's fanning out over time, mortality is. Disparity between states is growing. The spatial correlation is best illustrated here in the age trends. You can see that the highest age trends are all touching, right? They're all adjacent to one another, and the lowest age trends are all touching. They're all adjacent to one another. So this is an example of what statistically significant spatial correlation will look like. So I also included these markers in the states that are significantly different from 1 as far as the relative risk goes, significantly different from 0 as far as the temporal trend goes, and also the direction of the arrow is pointing whether it's significantly decreasing or increasing. I didn't do it for the age trends because everything is different than 0 there. And I think that it really, well, I think so because I made it. It does a good job of, at a glance, pointing out what the drug overdoses are doing. On the left-hand side, we're talking about all deaths. And on the right-hand side, I excluded the ICD-10 codes, which correspond to fatal drug overdose. And you can see that, at least for women, it took away a lot of the trends in a lot of the states. But the trends do remain here in the Deep South, in Appalachia, and what's this state? That's Nebraska. I don't know. You guys tell me what's going on there with the young women. In my discussion, I'm writing up this paper now. we're targeting a high-impact journal. So, I figured that now is my time to take risks as a postdoc. I can send this to a epidemiology journal. I might even send this to a statistics journal. But I wanted to take my shot at a PNAS, and that's where we were targeting this particular paper. So it's almost ready to go. It's going through kind of the co-author edits right now. And we're actually going to pursue the member submission track. I don't know if you guys know there are 2 ways to submit to PNAS. Does everybody know what PNAS is? Am I? Okay. So at the Cancer Institute, people do tend to publish in these kind of general readership journals a lot. Your New England Journal of Medicine, your Journal of American Medical Association, JAMA, even Science and Nature. So it is generally considered that Science and Nature are number 1 and number 2 in terms of kind of prestige and impact factor. PNAS is often kind of the 3rd one, the Proceedings of the National Academy of Sciences. And, well, I mean, yeah, if we get it in there, this would look pretty good on the LCV. So hopefully we will get it done. But that particular journal has 2 ways of submitting a paper. One is you just log on and submit it. And the other one is if you can approach a member of the Academy of Sciences, and you can get them to read the paper, and if they like it, they can submit the paper on your behalf. And on the website, if the member submits it on your behalf, your chances of acceptance are like 89%, because you already are getting a positive review before anybody sees the paper, basically. If you submit it via kind of the usual track, it's about 11% acceptance rate. So generally pretty low. So my current mentor, and the director of our department knows Sir David Cox of the Box-Cox fame and the Cox-PH fame. And so we're actually going to approach Sir David Cox with this paper. Because this
huge name.
Yes, of course. Now, he doesn't know I exist him, and so he needs to vouch for the statistics of this paper. Because, in a general readership journal, there's a word limit of about 3,000 words, and they don't care about your methods. They want you to drive home the kind of the public health impact of the findings. Like all the statistics go in a supplementary material, and I don't know how often you guys read supplementary material, but anyway, this is exciting. I don't know what my chances are, but I'm really into this project right now. Also, the model is so general. You can apply it to any outcome, any rate outcome, and instead of states, you can do counties. Instead of counties, you can do health service areas, HSAs. You can do congressional districts and voter turnout if you want. So really, I'm also hammering away in the paper at the applicability of this method.
Cool.
Also, this figure took a long time to make. And I'm so proud of it. Every color was specified by its hexadecimal value using colorbrewer.org, and I even tweaked them a little bit.
So what
so
package
these,
in R?
Sorry?
What package in R?
R color brewer, actually.
Well,
It's
for the plot itself.
Oh, this is the maps package. Maps package. This is maps package along with grid extra and lattice extra as well as in there. Grid arrange. Let's see what else. What other name? Oh, the symbols, right? They're Unicode symbols. So I had to look up the right Unicode for that stupid triangle, and the upside down triangle is different Unicode. Anyway, this paper took a long time.
For my other class where most of these students are in, Stat 850, which is Computing Tools for Statisticians. That name kind of sounds probably familiar to you. And
Yep.
we just got done with doing our graphics. We just did the graphics package itself. But later I might talk about ggplot2. I might mention grid.
Oh, I use grid all the time.
Yeah, ggplot2 is based upon grid. That's where it was built upon. So,
Right.
And it's
Right.
just a very general way of doing plots. And I think Pavel demonstrates that getting that plot right is so important because if somebody sees this in the paper, they're going to say, "Wow, that's really cool." And and while it takes time, in the end, it's most likely very worth it.
And especially if you're going for these, brand name journals, they're not looking for just good science, they're looking for sexy science. So we need to sexy it up a bit with our figures. And so I'm hoping this figure does it for them. All right, so let's get to the boring stuff. The postdoc details, the nitty-gritty. So this is actually a 3-year postdoc, which is kind of rare. Academic postdocs are 2-year postdocs. And actually, if I want, I can apply to get my postdoc extended for 2 additional years. That is not a useful thing to me because I'm on an academic track. I keep pursuing that professor position. A 5-year postdoc, I don't think that's going to be looked on very kindly in the academic world. But you can go and have a postdoc at the Cancer Institute and then go into a medical center. You can go into a cancer center. You can stay and do research here at the Cancer Institute, which is actually a great place it would be a great place to stay. They also have a tenure track process, actually, that is very similar to academia. And here, we don't have to apply for funding to do research. In fact, they almost pride themselves in doing research that would otherwise not be funded. So we can do all of the good science and replicability studies that are not funded by the NSF and the NIH. Money, for a postdoc, this pays very well. This pays very well for a postdoc. If you go into academia, the money you're looking for is usually in the low 40s. In fact, getting this position, I was also offered a postdoc at the University of Maryland, and their offer, which is exactly the same area, right? It is just outside of Washington, D.C., in the Maryland suburbs, which are an expensive place to live. And they offered me 45 to start, and they would not go up. I don't see how anyone can survive on that amount here. So 64 is maybe a big number on the screen, but it's actually not that much once you consider that rent is around $2,000 for a 1-bedroom apartment. My girlfriend and I share a 2-bed, 2-bath. We pay $2,700. So, but you know what? We're doing great. I travel. I eat out almost every night. I'm living it up. I'm not poor. Though, yeah. I went from graduate school to this, so don't worry about me. Stay in school, kids, right? That's the travel is, so we get $2,000 per year, and that usually translates into about 1 domestic conference. You can apply through additional travel funding, like I did with my last project, and then you can get another $2,000 for travel. Now this next year, I don't know how much your students know about statistics conferences, but both major stats conferences are going to be in the DC area. So ENAR is in Washington, DC in March.
Yeah, they know about the ENAR being there.
So if you guys come, please hang out. I'll show you all the places to go, and we'll have a good time.
Can you stay at your place?
I'll have to run that by my girlfriend first. But like, why are there 15 people showing up at our doorstep? So I'll definitely show you guys around, and maybe we can even arrange some kind of a tour at the Cancer Institute. They're always recruiting people. That's the thing. And if there is a big group coming from UNL, then maybe we can do something. And also JSM is in Baltimore, and where I live, which is northwest of DC proper, coming to Baltimore takes about the same amount of time as driving to downtown DC. In fact, it is so close that the U.S. government will not pay for me to stay in Baltimore. I will have to commute there, every day, but they will not pay for my hotel. They will pay for my car expenditures, but not for hotel. So I'll be able to go to 2 stats conferences next year, and with my with me winning the paper competition, I'll be able to go to a 3rd. So I'm looking at 3 conferences next year, which is pretty cool. If you wanted to get grant writing experience, being a postdoc at NCI is not the place to do it. Because I work for the federal government, I am ineligible to apply to most federal government grants. That is considered double dipping, and I just can't do it. I still can apply to private foundations, but I'm not as aware of opportunities there, so I'm not the one to ask. Mentorship. So I have a joint appointment in the biostatistics branch and the radiation epidemiology branch. So that means I get a mentor from each of the 2 branches. I do a weekly meeting with them. That is not a requirement, but in graduate school I've had a weekly meeting with my mentor, so I thought I was just going to implement that going forward. And that kind of keeps me on task and keeps them on task. That way I have to do something new every week and keeps me going forward. But really, postdocs are free to collaborate. I don't have to only talk to these people. I can collaborate with other investigators. I can collaborate with other postdocs. I can pursue independent projects. For example, I started a number of collaborations with psychologists at UNL, and we continue to publish together. So I'm not even bound to work for things in the Cancer Institute. I'm doing some consulting work on the side for the World Bank. So I like to say that once you get your PhD, you are responsible for your own brand. So I'm the Pavel brand, and I get to decide what this brand does.
Now, are all postdocs like that? I was kind of surprised to see the amount of freedom that you have to do what you want to do. I've always been seeing that postdocs here, let's say maybe a professor has some money, giving you, and then they hire a postdoc to do some specific research.
I think that's the real benefit of working here. That is the, put a gold star next to that. I think that you're right, Chris, that in an academic environment, I probably wouldn't have nearly this much freedom. But I love the freedom. I mean, I love the fact that I come in every day and I think of interesting questions for myself to answer. I don't have to submit funding for it. I just have to convince my 2 mentors it's worthwhile. And if I do that, I'm good to go. So it really is, that's the coolest part of my job.
Well, it's like you have an academic position without teaching, without the service component.
Correct.
And you just have the research component, which is then ideal then to find a position eventually in academia.
That's what I'm hoping. That's what I'm hoping. That's right. Oh yeah, and one little tidbit is that all manuscripts and presentations and abstracts have to pass through internal review before being submitted. And that's because I work for the federal government, anything I write can be misconstrued or construed as an official stance of the federal government. Now, I will note that this presentation did not go through internal review. And so please don't Facebook or tweet about it. I can get into a lot of trouble. But that said, I don't care. It's up on your website. Please leave it there. There's nothing secret in here. But if I was to, all of my officially submitted papers have to go through an internal review process first. And especially this mortality project, I'm talking about things like access to healthcare. I'm talking about things like affordable drugs. I'm talking about things like the Affordable Care Act. So you can see how what I write about those things will need to be carefully scrutinized. Yeah, so that's just, how it is. So favorite things, we've already touched upon a lot of this, but I don't really, no one tracks when I come, when I go, how long I stay, where I work. Some days I come in and I set off a model and I'm like, okay, well, this is going to take 6 hours. What am I doing here? It's a nice day outside. I'm going to go home and then log back in and then take a look at what the model produced. I don't have to work here. I can work from a conference room here. I can work from a coffee shop. I can work from home. If it's bad weather out, they're don't drive in. The traffic is bad enough. Go ahead and work from home. I have to write a lot. I write every day. And so they're like, yeah, write where you write best. If you write best at your cubicle, be there. If you write best in a coffee shop, be there. That is amazing. I wouldn't be able to do it any other way. If somebody tracked my every minute, I would not like that. Total control of the projects I work on, that's a big deal. I have responsive, engaged, and accomplished mentors. My mentors have a lot of, multiple years of experience. They've published a billion things. I feel like I'm getting a lot of good mentorship. Also, when I send them something, they take it seriously. I get my papers back with track changes. These things, frankly, get torn apart. And, a part of collaboration is working with your co-authors about, what it is I'm trying to say in this paragraph. Is there a better way to make this point? And then style, for example. So one of my mentors is an Oxford-educated mathematician. He's the smartest dude I know. But his style of writing is not the way I would do it. It's just not, okay? And we get into conflict sometimes about how to write something. But that's okay, because he's taking me seriously, and I'm learning a lot from him. So that is very, very important, to be taken seriously by your mentors. I work with great people. They're just, the fellows are very smart. They're smart in their own ways, and there are geneticists, there are physicists, there are statisticians, there are epidemiologists, there are people who know medicine, and I learn a lot from them just chatting at lunch. I learn more than I could ever about radiation and cancer than I could reading a book, frankly. And finally, I have a computer named Alice. Alice costs $15,000, and it was bought to me by my two mentors. It is all mine. Alice has 16 cores and 192 gigabytes of RAM. So I get to ask some pretty stupid questions. And if Alice runs out of memory, I know that either I did something wrong or it's not a question worth asking. So less than favorite things. There are some things about this postdoc that are not the best preparation for an academic career. And I'm coming at it from an academic mindset. And so if that's not what you guys want to do, then don't look at this bullet point, right? But really, most investigators actually don't publish in statistics journals, not even in the biostatistics branch. They publish in the Journal of the National Cancer Institute. They publish in the prostate, for example. There's a journal named Prostate. It has an impact factor of 16. Statistics journals have an impact factor of about 2, if you're lucky. So that's not to say these are not good journals. This is amazing science being published there. But I wonder how statistics departments would look at me if a lot of my publications were in these non-statistics journals. And I think a part of that is to publish quickly. I think the review time in most stats journals is just too long. So I was when I was working on this mortality project, they were like, wait, you have to get this out. You're sitting on a gold mine. You tell me you want to submit this to a stats journal? You're going to get your reviews back in a year? You can't do that. So I feel a lot of pressure to not submit to stats journals. And I have to stand up for myself and be like, that's really good for my career. And I will, I have to work on projects that are submittable to stats journals. But it just takes a little bit of planning. And most mentors don't come from academia. They are accomplished scientists, but it's rare to have a professor who leaves their job and takes a position here. There are people who do it. Like the director of our department was at Johns Hopkins for a while. I guess not. Someone came to the door, but then I stared them down. Salary is good for a postdoc, but it's not so good for a statistics PhD. If you're into an industry lifestyle, you can make twice what I make coming out of grad school. Easily twice what I make. The internal review process can be really annoying because the people who are looking at your papers are not necessarily other statisticians. They're people whose turn it is to do the internal review process. So sometimes all they do is they browse the abstract and they click the button, good to go, right? Because it's going to a journal anyway that is going to evaluate the scientific merits. But sometimes you get a picky reviewer who frankly thinks they know better than you, and they really don't. So you have to address their review, and it just takes time, and it can be really annoying. I'm over it. Also, I don't get to bring Alice with me, and that kind of sucks. I can write Alice in my starter package. Next place on that. Software. I didn't learn all of this software at UNL, but R definitely did. In fact, I learned R at Chris's categorical data analysis class. The best way to learn a software package is to be required to do it. And we were required to do it, and I had no choice. I had to learn R. Now that is literally the only thing I use. I don't use SAS. There are people here who use SAS, but all the statisticians use either R or MATLAB. There's a bit of Python in there, but that's mostly the physicists who use Python. LIX. This presentation was made in LIX. But I don't use LIX to write papers. And the reason for that is because all of my collaborators use Word. And so if I wrote papers in LIX, they would not like that very much, because they like to be able to open it in Word, mark it up, whole 9 yards. And I'm aware of there are probably capabilities in LIX that do that. It's just nobody knows about LIX here. I use WinBugs, JAGs, and STAN. So all three of those are Bayesian computation softwares. So they're technically standalone software packages, but they interact a lot with R. So WinBugs is the oldest, JAGs is the second oldest, and STAN is the newest of those. The differences are that, I don't know how much you guys know about Bayesian computation, but WinBugs and JAGs use Gibbs sampling. So all of your specifications have to be, conditional. STAN uses kind of that Metropolis-Hastings no U-turn sampling. It's called Metropolis-Hastings nuts. So you're more free to specify models. Your models can be much more general. And finally, EndNote. If you guys are not using EndNote yet, you absolutely have to start. Because I don't know how I got to grad school without a reference management software. I mean, I started one when I was writing my dissertation, but before that, I did a master's project, and I did lit review for it. It takes so long to set up your references section. It takes so long to find all of the references. You absolutely have to use a reference management software. And then when you move to the next place, you take your kind of your database with you. How many times do I refer to the AIC? Akaike 1973, 1956. Now I never have to find that reference again. It's always with me. Skills I use. I mean, these are general skills. I wrote statistical skills. I read so many papers. I enjoy it. I enjoy reading papers. Now I get to do it as a part of my job. I learned new things. I learned multivariate disease mapping. I learned how to specify these models. I learned H-period cohort analysis. I read a lot about mortality. So you have to be able to read and understand papers both in stats journals, in kind of general readership journals, and in medical journals. I have to write and verbally communicate with a statistical and non-statistical audience. I use a lot of generalized linear mixed models, especially the Poisson. That's because I deal with a lot of counts. I use a lot of matrix algebra. I don't use a lot of integration. Your stat 882, 883, you integrate a lot of things. And it's important to understand why you do, but at least in my experience, you don't integrate much when you get out of grad school. Maybe that's different for you, Chris, but... And then I personally use a lot of multivariate normal distribution because of spatial and spatiotemporal statistics. I have to know a lot about different parameterizations, different conditional specifications, vector notations, all that stuff. Yes.
We are running short on time.
Yeah, I was. Yeah.
Most go maybe 5 more minutes, and if students need to leave, you go ahead and leave. You can keep on going.
Okay, yeah, I'm sorry about that.
Okay.
So I'll be quick. I wish that I had more Bayesian statistics. I wish I had more of the EM algorithm, expectation maximization algorithm. I feel like a lot of papers I read use that, and that's not to say I don't understand any of it. I want to understand it better. Sparse matrices are very important when dealing with large data. Everybody's heard of big data. Well, the way big data happens is, I think, through a lot of sparse matrices. I wish I had a lower level programming language like C or Fortran to make stuff run faster. And finally, genetics. There's so many opportunities in genetics, and it's just not something that I will do. I try genetics, and I don't. That is not what I do. I put spatial thinking where spatial thinking hasn't been. I don't do genetics. General advice. I want to get this out. You're as a graduate student, you're going to fail a lot. You're going to fail, and boy, I failed a lot. Okay, I failed a lot of classes, and I had to retake them. Sometimes you feel like a failure when you're writing a dissertation. When you're a postdoc, you get rejected from journals. They just got a rejection last week. You gotta fail better. You gotta get over it. When you're a professor, you fail to receive grants. You submit a grant proposal and you don't get it. It's not the end of the world. You have to learn to fail better and just get over it. Yeah. You have to stand up for your research. You have to don't let anybody mold that into what they think it should be. Respectfully argue with your mentors, advisors, and co-authors. I think it's a good thing. If you're in the academic job search, it starts 1 year in advance and takes a very long time. You got to plan it accordingly. And in this line of work, you're going to be a nomad for a few years. Going to a postdoc, that's not a permanent position. Then going to your first professor position, chances are you might leave midway through the tenure process. That's not at all uncommon. Publishing, quality over quantity. Don't get into measuring contests. I work with some people who are all about the impact factors, all about citations. All of those things are important. Just don't get into a measuring contest. Many good journals. You don't have to start your paper with science. If it's not in science, it's worthless. There are many good journals. Publishing the stats journals takes a very long time. Working with data, back up everything and use Dropbox. Because I so benefited from this when I was writing my dissertation. Dropbox has an automatic rollback to previous versions. So you can log on and roll back to whatever version you want for the last 20 versions. So if you mess up the code and you accidentally save it, you get to roll it back. One thing I started doing was I started saving my R workspaces every so often. So not only just the code, but the entire workspace. And then again, sometimes, when I'm working on something, I'm developing something, it helps to go back and get all of the R objects. And finally, this was a big deal for me because I got into trouble with my dissertation. I was only now able to submit it because apparently my collaborator didn't put me on the internal review board documents. And so technically she was not allowed to transfer the data to me, the EEG athlete data. And so we got into a lot of trouble. We had to go through a formal IRB hearing. The lawyers got involved. It's all settled now, okay? But it took a year. That is a year where the dissertation could have already been published. And we got lucky, frankly. Because this was transfer of sensitive information, and I had no standing as a statistician, right? I had no standing because my name was in none of the IRB documents. So officially, I was SOL. So make sure if you use somebody else's data, make sure your name appears in all of the right places. Finally, make friends, guys. This stuff, graduate school can be very, very stressful. Postdocs can be stressful. Professors' positions can be stressful. Use the emotional support network. Your fellow students, postdocs, know exactly what you're going through. Use them for emotional support. Thank you very much.
Well, thank you. You have to go. I have one question.
Yeah.
And since we're out of time, how do you make the decision between going on for a PhD rather than stopping for a master's?
I got a high pass on my what's it called, the qualifying exam.
Yeah.
I tell you what, I wouldn't be able to retake that thing. I don't know. I got too emotional about it. I too stressed out. I frankly didn't think I could do it, and when I got a high pass, I kind of said, oh, maybe I can do it.
Well, I mean, it's not necessarily just that. I mean, obviously, you have to have that high pass, yes.
Yeah.
But it's not necessarily just that. I mean, do you want to stay for at least 3 more years? I mean,
sure.
you know.
Yeah, you're right. You're right. I was able to, given my family life, given I said lack of a family life, given my financial situation, I could stay for 3 years at a 15 grand a year job. And to be perfectly honest, I took some loans out to kind of have a bit of a life while I was a graduate student. And I was able to put those in remission, or no, not remission, whatever, deferment. Thank you.
Yeah,
So I'll have to start paying them off once I get my next position.
I'm here, and we are done for today then. Okay.
If there are questions, your students and you, Chris, you guys are always welcome to email me. My email is pavel.chernyavsky@nih.gov. You can look my name up. I'm on Google Scholar, ResearchGate, the whole 9 yards.
Me too, and I'll pass along.
Right. So please, if you have questions, if I can be helpful, please let me know. Thanks, guys.
Thank you.
Bye.